My name is Jay Mizunan. Today we are going to talk about topic RF and wireless. I will be explaining the introduction part for this topic. Okay, what is RF and wireless? Okay, the term wireless RF stands for wireless radio frequency technology. Radio frequency. Radio frequency is a measurement signifying the oscillation rate of electromagnetic radio waves or electromagnetic radiation spectrum of frequencies ranging from 300 GHz to 900 kHz. With the use of transmitters and antennas, the radio frequency field can be used for several types of wireless communication. Wireless radio frequency is any of the electromagnetic wave frequency that lay the range ranging from around 3 kHz to 300 GHz, which comprise those frequencies used for radar signals or communications. That's all from me. Thank you.
Hello, and my name is Muhammad Aiman Muhammad Alam, and I'll be presenting about the RF and the wireless history background. So first of all, the picture in the slide is Guglielmo Marconi, which is an Italian person born in 1874, and he studied in University of Bologna. The reason he started working on radio transmission because of the German physicists. They found the radio wave, and he was really excited with that. And then he started struggling in 1894 until 1901. He succeeded to receive the first he received the first radio transmission across the Atlantic Ocean, which is measured about more than 2,000 miles. This is to prove the radio wave did not travel in straight line like the other physicists say. For example, other physicists believe that the radio wave does travel in straight line, but Guglielmo, he believes that the radio wave follows the Earth curvature, and because of that, he successfully sent a Morse code signal, which is for S, across the Atlantic Ocean. The Morse code he received in Newfoundland, Canada, is from Cornwall, United Kingdom today, which is measured by, like I said just now, is more than 2,000 miles, and it is really amazed me how he successfully did that in that moment, in that time. And because of his big achievement in sending the farthest radio message at the time and able to prove the other physicists about the theory of the radio wave, he was announced to receive the Nobel Prize for Physics in 1908. And because of that, some people called him the father of the radio. And I would also really want to appreciate him because of his success. We are now today able to reach anybody from any state without any problem. And that's all about the history of the RF and the wireless. And I'll pass the speech to my friends.
Assalamualaikum. Assalamualaikum. My name is Abdul Mohim bin Mahmud. My number is 202010551, and I'm here today to talk about the application of RF and wireless. The radio frequency is measured in units called hertz, which denote the number of cycles when the radio signal is transmitted. 1 hertz equals to 1 cycle per second. Radio waves range from 1000 kilohertz to millions megahertz to billions gigahertz of cycles per second. Microwave are the kind of radio wave with higher frequencies. Radio frequencies are not visible to human eye. In a radio wave, the wavelength is inversely proportional to the frequency. If the frequency is measured in megahertz and the wavelength is measured in meters, then as the frequency is enhanced beyond the RF spectrum, electromagnetic energy takes the type of IR, ultraviolet, visible, X-rays, and also gamma rays.
Thank you for previous presenter, Abdul Mohimin. Now, my name is Ashraf Kimi Basharuddin. Now, I would like to continue the presentation about operating frequency. Uh, in operating frequency, it have 0.1 megahertz until 10,000 megahertz. So for 0.1 until 1 megahertz, uh, 0.1 until 10 megahertz, it used for closed looping systems, closed via electric or magnetic fields. It is used for electronic door, locking system, and contactless payment card. Next, uh, for next operating frequency is 10 megahertz until 100 megahertz. It used for remote cloaking system. It is inductive radio system using magnetic cloaking between reader and transponder, and a few system with capacitive electric cloaking. It used for contactless smart card like ticketing, animal identification, livestock, industrial automation, near field communication. It is NFC and data transfer. Next is 100 megahertz until 1000 megahertz. It used for backscatter system. It is retail inventory management, pharmaceutical, anti-counterfeiting, and low power sensor. It is wearable monitoring device. Next, for 1000 until 10,000 megahertz, it used for long-range system, backscatter system, active, surface, acoustic with transponder. It used for asset tracking, real-time locating system. It is RTLS, toll collection, wireless device, configuration protocols, Bluetooth, BLE, and operating frequency for 0.1 until 10 megahertz is used for LF. It is 125 until 134 kilohertz. For 10 until 100 megahertz is used for HF. It is 30.56 megahertz, and 100 until 1000 used for UHF 433 and 868 slash 951 megahertz. And lastly, for 1000 until 10,000, it use MW used for 2.4 until 5.8 gigahertz. It's all for me. Thank you.
Hi, my name is Nur Safia Afikah. I'm going to present about future trends of wireless and RF technology. We all know that wireless technology has grown tremendously over past these years. This trend is also obvious because technology innovation will increase at a fast rate in the future. This has been particularly true, especially in communication, as radio frequency technology has become popular and important in our daily lives. There are 4 points that we can discuss about future trends of wireless and RF technology, which is 5G network, satellite communication, defense radars, and autonomous vehicles such as cars. First is 5G technology. 5G technology or network. Yeah. If you have been following the trends of RF fields, you probably know that the upcoming 5G revolution that will replace 4G, which is one of the biggest changes in RF and wireless technology. If you went to electronic markets, you will notice few phone brands such as iPhone and Samsung that sell 5G phones, as it provides faster internet connection comparing to 4G phones. This technology is also good for artificial intelligence. Second is defense radars. Actually, defense radars and satellite communication are related because we send signals from Earth to satellite to communicate with others. Um, you can expect that in few years in the future, you will see several innovations, improvements, developments, and challenges surrounding both aerospace and defense and defense and radio frequencies industry. With the existence of IC, which is integrated circuit, it will improve the performance and lessen the cost of the radio frequency field. And then lastly is autonomous vehicles. We can actually see that cars like Tesla has been using this technology. And autonomous vehicles are made from combination of sensors and actuators, sophisticated algorithms, and powerful processors to execute software. Actuators is like a device in a machine that will make the machine operate. And sensors will use radio frequencies to sense what is on the road to maintain the user safety. By using GPS, you will arrive at your destined location. That's all from me. Thank you.